so on. So basically what we want to do for this exercise is that we're going to actually observe the movements between the frames that we have. So we have some frames here. This is frame 1, 2, 3, 4, and 5. So what we're going to try to do is to see what transformation took place between the frames. For example, so we're looking at this. So frame 1 to frame 2. So basically we are observing what took place between this to this, right? Now, there are a few things that we want to take a look at. One, the size remained the same. It's the same size. The orientation of the two images looks the same, or the two objects. So when we take a look, we do realize that this point here is still pointing in the same direction. So we're seeing that this is a translation, right? So remember, a translation is just a slide. So this was just slide to there. Let's take a look at 2 to 3. So the second one, we want to look at frame 2 to frame 3, like right here. As you could see, when you observe this, it does look like there is a flip. So I'm actually seeing like there is a line of reflection here. So it was a reflected across. So 2 reflected across to 3. So this is a reflection. Right. Let's see what happened between 3 and 4. If we observe 3 to 4, these two frames, we're noticing one, it's not a translation, it's not a reflection. It's not a dilation because it did not enlarge or it did not diminish. We do realize that we saw where it was turning, right? So this is actually a rotation from 3 to frame 4. Frame 3 to frame 4 is actually a rotation. Let us look at frame 4 to 5. As you could see in frame 4 to 5, this just moved down, right? So it just moved down. So basically what we're seeing here is another translation. So there it is. We were just trying to identify the type of transformation that took place, right, in these 4 frames. Let's take a look at question 5. So in question 5, it says the triangle RHB is shown on this circular graph. So we're looking at that circular graph. So what we're required to do is to plot each of the points. So we're going to plot each of the points. So here, to plot W, right? So to plot the point W, we're going to plot 120 degrees, right? We're going to plot 120 degrees on circle B. So we're going to go where circle B is, and then we look for 120, mark that spot. For example, this is circle B right here. So on circle B, we're looking for 120 degrees. So it's going to be right here. This is W. Now for Y, this is Y. We're going to go on circle R, and then we're going to plot 150 degrees. We're going to put a mark there. That's going to be our Y. So let's take a look at the R circle. This is the R circle going around here. That's the R circle. So on that R circle, what we're looking for is 150, which is right here. So this is Y. Point K is on circle H, and it is at the 300-degree mark, right? So it is at circle H, it is on it at the 300-degree mark. This is circle H. So on circle H, we're looking for the 300 degree mark, which is right here. This is the 300 degrees. So this is K. Let's look for T. T is actually on the B circle, and it is at the 330 degree mark. So the B circle is this circle right here. And we're actually looking for 330. So it's right here. So this is T. Lastly, we're looking for G, but G is actually, it is on the R circle, and it is going to be where 360 is. So it's going to be on this, it's right here. And so we have G right here. We're going to connect these quickly. All right, so let me try to connect this. So bear in mind, though, that, all right, so we're going to respond to some questions now from this. Bear in mind that this original HRB, this is originally our pre-image. It's the original one. And then we actually have image here. That's an image that was produced from it. So I could say that's image one. And this is a second image that was produced from the pre-image. So that's image two. So I'm just labeling those. Let us see what the questions are, all right? So here's a few questions. It says, so complete the statements, all right, about the triangles. So it says here, triangle HYW is a blank of HRB. So let's take a look at them. They're asking us, right? What is the relationship between this and this? As you could see, based on what we did, I'm actually seeing that we do have an imaginary line here. If you look at this line here, it acts like a mirror, right? It does act as if it's a mirror right there. So I'm actually seeing a reflection where that purple line that I just put here is, this line is the mirror for it. So it's a reflection. So that's a reflection right there. Let's go back to it. So it's a reflection. So we want to tick this off. Now, the second question says, GKT is a blank of triangle HRB. So what is G? What is this one here? GKT. And if you look, this one here, all right, you can see it's turning, right? So basically, what we do have is a rotation coming this way. So G, which is this one, GKT, is a rotation of that. So this one is a rotation. We could mark it off. All right, let us follow through. This question says a diagram of W and RB and W prime, N prime, R prime, B prime is shown. Arrows are drawn from vertex B to vertex B prime. All right, so we're seeing what's going on there. So here's a question. Complete the statement. The arrows show a possible path of movement. This path is called a, take a look. When you look at these words, is this a reflection? Is it a rotation or a translation? Based on what we're looking at, it looks like there is some sliding going on, right? So because I'm seeing sliding, it is definitely a translation. So that's a translation going on there. Let's take a look. It says the same path blank for all points on the diagram. So we want to take that the same path exists for all points. In other words, then let us take a quick look. The path, what path? Let us look on B. So we want to observe from B to B prime. Look what took place. We had a movement of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the left. So we saw 10 to the left and then 1, 2, 3 up. All right. So from B to B prime, you move 10 to the left, 3 up. Let us take a look at moving from, let us say, from R to R prime. Take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. So from R to R prime, we're getting the same 10 to the left, 3 up. Let's try W. All right, good stop after that. So look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the left, then 1, 2, 3 up, and we're at W. So we are noticing that we're getting a standard movement. The path, right, is 10 to the left, 3 up for all points from this figure to produce that, right? So that's why we said that the same path exists for all points on the diagram, that same movement. Now, the path is called a mapping. The path is called a mapping. So that 10 to the left and 3 up, that is called a mapping. So let us take a look at number 10. Number 10 says, the transformation shown on the grid can be referred to as, we could call it an isometry. Now, remember isometry. This prefix iso means same. So what would happen in this is that the reason why we call these isometry is because both the image and its pre-image, they are the same. Take a look. It's the same size from B to B prime to W prime to BW is the same. R prime to N prime to Rn is the same. We're noticing that all the lengths from this pre-image is the same as its image. The shape, everything, the size, the angles inside, everything remains the same, right? So because of that oneness, because we're getting congruent, right, shapes. So with the isometry, we are going to get what we call congruent, right, shapes. So because we got those congruent shapes, they are called isometry, right? Or as a rigid motion. So it can be referred to as a rigid motion, right? So that's a rigid motion because when it was done, it preserved, right? So the key thing is, take a look. Why is it that we call it a rigid motion? Because the transformation preserved the angles and the distance. So you're noticing that the angle and the distance were all the same. Hence, it produced the exact shape. And that is why we use the word congruent, right? So we end up with a shape that is congruent to the one before, right? So basically, that is just a quick introduction to isometry, rigid motion, the transformations that are actually rigid motion. Because when you look at this that we did earlier on, this, we actually did 3, watch, translation, reflection, rotation. We did 3 types of transformation and from 1 to 5. And look at the shape at 1, look at the shape at 5. They're all, it is the same. So even if it was turned, when you look at the angles inside, the length of the various sides, the area of the two things, when you compare them, you realize that it's the same. These transformations are actually called isometry, or we could refer to them as rigid motion. These are rigid transformations, right? Take care. See you next time.